Okay. Um, Here's a question dealing with average rate of change, right? Average speed. Sometimes we call the average rate of change. We abbreviate it as AROC, average rate of change, right? Um, when you talk about average rate of change, this is a term that we use in calculus because the motion of an object is not constant, right? There's acceleration, there's deceleration, there's change in direction, and every time that happens, that creates a wiggle in the graph, right? It creates a bend. It's no longer constant. So, but I want to be clear about one thing. The average rate of change is a slope. Okay, and because it's a slope, it's still the change in y over the change in x, right? Our y and our x are, obviously take on different variables and different meanings, but that's really what we are talking about. So, specific to this question, a hypercoaster is a special circuit roller coaster with a height measuring greater than 200 feet. If a new hypercoaster is under design to have its largest drop on the circuit modeled by the equation below, where d of t is measured in feet and time is measured in seconds. So here is your y, right? And here's your x. Your independent variable is time, your dependent variable is feet. So really specific to this question, we're talking about the change in position over the change in time. I want to show you two ways to calculate this using Desmos, right, as just a quick way to do that. So when we talk about the average rate of change from 2 seconds to 8 seconds, these are measurements of time. One way to express that is we want to know the position of the roller coaster at 8 seconds, and we want to subtract that by the position of the roller coaster in 2 seconds, right? The second measurement minus the first. And then the change in time, of course, would be 8 seconds minus 2 seconds. This expression right here, okay, is change in y over change in x. Excuse me. So it really is that simple, but because of how complicated some of these problems look, it gets, and the calculations get kind of crazy, right? So I want to show you two different ways that you can do this using Desmos. I'm a fan of Desmos. They don't pay me, they don't endorse me to do anything like this, but I prefer it to the Inspire. I'm going to show you how to do the Inspire for something else in a separate video. So what I've done is I've already plugged in that formula for D. I didn't put D of T, obviously, because Desmos isn't great at understanding variables like that. But what I've done is left a blank here, right? Because that's our independent variable. So two ways you can do this. One way to do D of 8, right, is just to plug in 8 here. And this is what makes Desmos great, in my opinion. Okay, I feel a sneeze coming on, so I apologize if that happens. But if I plug the 8 in, I get my value of 671.36. So I'm just going to come back here real quick. I'm going to say 671.36. Okay. And then D of 2, come back here and just change these to 2's. I don't have to retype the expression, right? That's one of the positives of Desmos. Your TI Inspire, it's a little bit more cumbersome to do something like that. So we get 290.54. But all we're doing is plugging in these numbers into this expression, right? And getting those Y values. And then we can subtract this. And this is an expression that you can just type back into Desmos. All right. Second option, maybe a little bit easier, is to type the actual function in. And again, don't use D and T, use X and Y. Okay. And then after you type in that expression using X's instead of those blanks, if you come up here to the gear, we might have to highlight this one. I think we have to highlight that row. Come up to the gear and click table, right? It's going to populate a table for certain values of X. And it's kind of intuitive where if I just hit enter, 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 I'm getting the outputs for those various values. So here is the output for what, oops. Go back. No. There it is. This is the output for when X is 2 or T is 2. This is the output for when T is 8. Those are the same numbers I got by plugging them in. So using a table to plug that in. So again, how do I create a table for a function that I've already plugged in? And this is going to be important later on when we start looking at limits. If you go to the edit list gear and then you just click the table button right next to it. You get a new table for that. Okay, and that helps us come up with these values here. And then if you do this calculation, just to put a nice bow on it, you get 63.47 feet per second. So during the time frame of 2 seconds to 8 seconds in this hyper coaster, okay, the average speed of the coaster itself is 63.47 feet per second. That's not a constant speed. Sometimes it's going faster, sometimes it's going slower. But during that time frame, it's 63.47.